Welcome to the top 12 reasons to use the systems engineering process for your smart city project. I'm Jim Frazer. I've developed this companion video to communicate and demystify the dramatic benefits received through the use of the systems engineering process, abbreviated SEP, with a particular focus on smart city applications. In this video, we'll quickly examine the systems engineering process. Next, we'll discuss the value of technical standards to the process. We'll describe challenges to the process and how to overcome them. We'll introduce a number of real-world lessons. And lastly, we'll review the top 12 reasons to use SEP for your smart city project. Before we examine those benefits, let's first examine exactly what is the systems engineering process and why it's important to developers and operators of smart city projects. The systems engineering process is a design and testing approach which facilitates delivery of complex systems. SEP focuses on first defining customer user needs, next the required functionality, and lastly proceeds with testing, also known as system validation. One way to represent the SEP graphically is by using the systems engineering V diagram. This diagram represents the typical life cycle of any system or project. Regardless of system's complexity, all systems will follow some variation of this full life cycle. In step 1 of the V model, user needs are generated through a robust examination of needs from all stakeholder communities that have an interest in the envisioned project. In step 2, each of these needs are used as a foundation in order to develop measurable, unambiguous functional requirements. Each need must have a functional requirement, and each requirement must have an underlying foundational user need. The last step in this process, step 3, is to create a test plan that confirms the traceability of needs to and from their dependent requirements. When developing your smart city system, the focus needs to be on exactly what the system needs to do and not on how the system will do it. Within the SEP process, a traceability matrix is used to document and verify these critical relationships. The matrix may be maintained directly in a database or a spreadsheet for smaller projects, or it can be generated and maintained with a requirements management software tool for more complex projects. Using either approach, the matrix provides backwards and forwards traceability between stakeholder needs and other potential requirement sources, and the dependent system requirements, design, implementation, and verification test cases. Next, let's examine the value and role of standards within the systems engineering process. Standards are primarily used in the design stage of the systems engineering process after the higher level activities, such as user needs assessment and the concept of operations, have been developed. Remember too, that standards can also provide critical user operational needs as well as interface requirements during the project definition stage. Now that we have examined the systems engineering process, let's discuss a number of challenges that often occur when using this approach. Technical challenges often include the following: gaps in existing skills, inconsistent industry support for standards, conformance to standards, the paradigm shift that must occur from non-standards solutions to standards-based solutions, as well as the paradigm shift that results from shifting from non-SEP-based solutions to systems engineering-based solutions. Institutional challenges include the following: not everyone in an agency is willing to articulate their needs. Cultural resistance to change and siloing is an issue. Not all agencies support regional integration. Not all siloed activities embrace integration either. The paradigm shift from non-standards solutions to standards-based solutions is also an institutional one, as is the paradigm shift from non-SEP-based solutions to systems engineering-based solutions. Next, let's examine a number of real-world lessons. Functional integration is a subset of the systems integration process. During this process, system components are assembled into a working system and verified to ensure that they fulfill all of the system's requirements. Assembling a puzzle is a helpful analogy for this step. The challenge in a smart city project puzzle is that not all of the pieces are available at the same time. Some will not fit together particularly well at first, and there will always be pressure to change some of the pieces after having already assembled them. The intent of jurisdictional integration is to integrate the processes that allow seamless coordination among jurisdiction and siloed activities, although the jurisdictions do continue to operate as separate geographical, functional, and political entities. Technical integration issues relating to jurisdictional considerations involve both of the design and the implementation of particular solutions, as well as the coordination issues among regional and other siloed entities. One of the largest and most common hurdles when developing smart city applications is to make them compatible with the existing systems that are already out in the field. There are several important factors that must be considered when integrating new systems with existing ones, and that can have significant impacts on the system costs and the deployment schedules. These issues include integrating with existing legacy systems to save costs associated with implementing new systems, as well as complying with standards whenever and wherever possible. Now that we've briefly established the foundational knowledge of SEP, we've discussed standards, challenges, and a number of real-world lessons learned, let's review the very dramatic positive benefits received through the use of SEP. In summation, SEP offers a wide variety of benefits to smart city project stakeholders. These include, but are not limited to, the following. Number one, SEP helps define the scope of smart city projects. Number two, SEP drives a higher level of stakeholder participation. Number three, SEP increases the likelihood that the smart city system meets user expectations. Number four, SEP generates better smart city system documentation. Number five, SEP reduces the risk of cost and schedule overruns. Number six, SEP minimizes defects in accepted products. Number seven, SEP drives more predictable outcomes. 8. SEP provides a framework and a process to verify that the smart city system meets documented user needs. Number 9. SEP provides more adaptable, more resilient smart city systems. 10. SEP, through the testing process, verifies system functionality. 11. SEP allows a higher level of reuse from your original smart city project to projects in the future. And number 12, SEP is required for access to U.S. Department of Transportation funding. For more information on that, you can see U.S. DOT Rule 940. If you have questions or comments about SEP or anything else in this video or white paper, please call me directly or email me at the contact information below. Thank you very much. Welcome to the top 12